Hey viewers, welcome back to the channel. Hope you are doing extremely well. So today we are going to discuss interesting question on the binary tree, that is transform to normal from a left clone binary tree. So without wasting time, let's move on to the question. In this question, we are provided with the binary tree. Let me create a clone binary tree. Before that, A, B, C, D, E, and F. Its clone will be nothing but A, B, B, D, D, and B clone will be nothing but E, E. Okay, A has a child C, C clone C, F, and F. Yeah, it will fine. Okay, so in this question we are provided with this binary tree. And we need to modify it in such a way that it get in normalized, means all its left clone tree nodes get removed out from the tree and it get modified into a normal tree. So I hope you get it. Means what we need to do in this question is uh, we need to modify this tree in such a way that these clone nodes get removed. Okay, these nodes get removed and our final output will be look like the normal binary tree. So I hope you got the question. Try to pause this video right now, try to solve it by yourself, and after that watch the solution video. I hope you got the I hope you tried it by yourself. Let's try to get how do we approach to this problem. Okay, so let's discuss the problem statement again. We know here we are provided with a clone binary tree. Let me create it. Its clone will be nothing but A, B, B, D, D. A child has C, C clone will remain C, F, B child will have E and E. Okay, so we have this clone binary tree and we need to modify it into a normal binary tree. So what will be my approach in this problem to solve this question is that here I'm going to use the same faith that each node will say that I don't know how do I modify my children's, but I know how to modify myself, and my children know how to modify themselves. Okay, when my children modify themselves and they come out with the updated result, I will modify myself, I will update my links with them, and as a result I get my normal binary tree. Means this A will say that I don't know how to modify my left children and the right children, but my left children and right children are sufficient enough that they can modify themselves itself. Okay, so A will say that I don't know how to modify this subtree, how to modify this subtree. Okay, but they know how to modify themselves. So I make a call to the left hand side, to the right hand side. Okay, I move to this B just because this is a clone node. Okay, so I make a call to this B. Let me erase something so that it will be, so this A call to this B, that yeah, do you know how to call? So okay, so when we move to this B node, this B node will say that I don't know how to modify my left children's and the right children's, but yeah, I know that my left children and the right children are sufficient enough that they can modify themselves. Okay, so when they come up with the updated result, I will update myself and update the links with them, so it will call to its left children. Okay, so here you can see we are calling our Euler in a different format, like uh, we are leaving the clone node each time on the left hand side. Okay, I hope you get it. Why are we doing this? Just because it's, if we talk about the left children, the A left children is not A, it is a clone node. The A left children is the B in the normal binary tree. So that's why we are leaving one node each time. Okay, now let's move to the D. D will say that yeah, I don't D will say the same, that I don't know how to modify myself, sorry, how to modify my children's in a normal binary tree. Yeah, but yes, my children's are strong enough that they can modify themselves, and when they come up with the updated result, I will update my links with them and I will update my self and remove my clone node. So it call itself, here is the null, it called its right child, here is the null. So we return the null from here, now the D will say that I get data from my children's. Now I will modify myself, it will remove that node and I will update my links with my children's. So we update this links. Okay, move to this B will say that my children's call, some calls are remaining, so it goes to this E. Now here you can see that in the left hand side we are making our Euler to left one node each time during calling, but on the right hand side we are not leaving any node, we are just calling node dot left, sorry, node dot right, just because we know that our tree is left clone, means all the clone nodes are available only on the left hand side, not on the right hand side. That's why this side we call to our next node here, this C, and we ask the C to do the same. But C will say that I don't know how to modify my children's, but yeah, my children are strong enough to do it by themselves. Okay, so I call to my children, and when they come up with the result, I will update myself and update the links with them. So F will say the same. Okay, so here you can see F children are null, they come up with the null. So F will remove this node, update its link with the children. So here will come the null, here comes the null, and F return itself. Now the C right hand child is null, C will say the same, sorry, C will do the same. C will remove this node and C will update its link. Okay, let me make this link with C will make its link with this 5, and here it make its link with the null. Now you can see here from the left hand side I get a modified tree. Modified tree means modified into a normal tree, and from the right hand side I get a subtree which is modified into a normal tree. Now A will do what A will do. A will say this, A will do the same. It remove this node, and after removing the node, it updates its link with the left child and the right child. So let's try to code it on the editor, and then we try to dry run our code. Okay, so we are going to write our code on the Pepcoding portal here. Okay, so at first we are going to make the left call, left child, this same function. Okay, node dot left, just because all the clone nodes are present on the left hand side, that's why we are making our Euler to leave a left node each time. Similarly, we can make a right call, control V, node dot right. Okay, now a node, now the node left children's and right children's have modified themselves, and they come up with the updated result. Now what I'll do, I will update the node left with the left, and node right with the right. Okay, now let me, and at last it will return itself, return node. Let me handle the base case. So if node will be null, I will just return null. Let's try to run it at first. So we get a compilation error. Okay, we have written node.left equals to left, where okay, it is not left, we have stored the data in LC and RC. That was a typo, I have a ping mistake. Okay, so let's again try to run it, and it get accepted. Let's try to submit it. So we get the correct answer. So let's try to analyze it. Okay, yeah, let me take this code on our whiteboard. So this is your code, and let me make a clone tree. Okay, for this let me make a small tree, A B C D E, and here is the, so our clone tree will be nothing but A B B D D. This A has a child C, its left clone is C, F and F. This B has a right child E has a left clone E itself. Okay, so this is our left clone tree with which we are provided with, and we need to modify this tree. Okay, so how we are going to modify it? Here you can see that this, at first we come up to this node A, and A will say that I don't know how to modify my children's, but my children's know how to modify themselves, how to make themselves transform from a left clone tree to the normal tree. Okay, so it makes a Euler to call to its children, left children. Okay, so A calls to the B will say the same, that I don't know how to modify my children, so it will make another call to its children, that is D again call to its children. Here's the null, so it get returned, it get the value from its children, it is null. So what it does, it remove this node. Okay, so here you can see we are returning null. From here the null is returned and we update its left node, so this link get break and it start pointing to its left children, which is nothing but the null, and its right children also start pointing to the null. From here I return this node. Okay, here I'm returning this node. Similarly for B, I'll make a right call. Okay, this E will say, here I'm updating the Euler normally, means I'm not leaving any node during calling to my children's. Okay, here you can see, just because here the clone nodes are not present on the right hand side, we know that's why we are making normal right calling. And during the calling you can see that we call the E will say the same, I don't know how to update my children's will do it by themselves. So from here it gets the null, from its children it get the null. What it does, it just break this link and it updates its link with the children. So here its left node will become null, its right node will become null. I know it is getting a little messy, let me remove some. Okay, so this link get break, so this node get removed actually, so its left and right will become null. Now what happened, B left children is already updated, B right children is already updated, and they have returned themselves with the updated result. So what the B does, B node will do the same, it break this link, it update it link with the left child, it make this link and it make it link with the E. So means these nodes get out removed from the tree, these nodes will no longer be the part of the tree. Okay, so here similarly A will call to its right child will do the same, C will call to its children F will do the same. Okay, C calls to the F will call its children return null, so means F updated link with these children, so this link get break, this node get removed from the tree, and here F left and right become null. And similarly F return itself as a left child of the C, so C get its left child in F and C right child is already null, so C also update its left and the right child links with the F and the null. So this node get removed from the tree, it will no longer be the part of the tree, and its C left and right child links get updated in such a way that it left child will become C and right child will become, so C's left child will become F and right child will become null. So now as you can see here, A left child is already updated and A right child is already updated with the modified nodes. So now A will get its left child and right child updated solution, and it will update its link, A updated link, so that it start pointing to this B only, and A update its right link so that it start pointing to the C only. So what we'll get at the end, this link get break and only this link get established. Okay, only this link will remain, so at last we'll get nothing. Actually I just forgot to remove that node, this node is already removed out. Okay, and D was pointing to null. So here you can see that all those nodes which were cloned are already removed out from the tree. So I hope you got this solution. If you like this video, don't forget to hit the like button, subscribe to our YouTube channel and share it with your friends. Till then, stay safe, stay healthy.